Yeah. Actually, really accurate.
Yeah, that's like the only way I know what it is. Okay, so, if you weren't here yesterday, we just, did a little bit on 10.03. Which is just, properties of logs, so, on page 6, if you didn't get a chance to copy this down, go ahead and do that. And I'll also, write this, at the top of page 7. Okay, so we talked about how, logs feel complicated and abstract, but really you're just trying to figure out how to get that exponent, by itself, in a way that will allow us to solve for that exponent. So on page 6, I have these, properties. It looks more complicated because it has the base B. But as long as the bases are the same, all these properties can stand. So I rewrote the properties on the board here without the base, just to make it a little bit easier to see the connection here. So if I have the product of two terms inside the log expression, I can expand that out into the sum of two log. If I have within the log expression a division quotient of terms, I can expand that out into the difference of two logs. If I have a log of u to the nth power, I can bring that exponent down in front. This is really the nicest property of logs, because normally we can't just bring an exponent down and keep the same value, but here we can bring that exponent down in either location, and they both represent the same value. So it allows us to solve for problems that otherwise would be difficult to.
What about like a square root with it?
A square root, you can rewrite it as it's the 1/2. So if I have log of x square root of x, that's the same thing as log of x to the 1/2, and that 1/2 can come down in front.
Oh.
So let me go through some of the problems that I did yesterday in class. So on page 7, we talked about how we can expand these terms, because you see that 2 and the x are kind of representing the u and v, so we can expand it into log base 5 of 2 plus log base 5 of x. Okay, for number 2, notice that this is the product of 3 terms, the 8, the a squared, and b to the 5th. I can expand that out into the sum of 3 logs. Log of 8 plus log of a squared plus log of b to the 5th. And then one more thing we can do is we can bring the exponents down in front to further expand. So the problem, the direction says expanded expression should have no arguments. I should have arguments with no exponent product or quotient. And then number 3, I have the quotient of g and h. I can expand that into log base 7 of g minus log base 7 of h. So here's the big picture that will allow you to expand properties quickly. If I have, let's say, log of AB over CD, anything in the numerator is part of a positive log expression. Anything in the denominator is part of a negative log expression. So in this case, if I had the A and B up top, it'll be log of A plus log of B. Anything in the denominator will be part of a negative log expression. Okay, so try number 4. We have 16 and W cubed up top. We got X to the 6 in the bottom. So we know that 16 and W cubed will get the positive treatment. And then the X to the 5th will be, X to the 6th will be a minus.
What if you put it parentheses and add them and then you subtract it?
Yeah, but eventually it's gonna end up being subtracting, so I'm just skipping that part and just going to the end. Yeah. But yes, technically they are being added and distributing, but we can just skip that part.
Would be the same for like natural log and all those properties?
That's right, natural log would be the same
Just like a
properties.
base heat, like.
base heat, that's right, yeah. So this is what number 4 looks like. Log base 4 of 16 plus log base 4 of W cubed minus log base 4 of X to the 6th. And then to go even further, we can bring the exponents down, and that's our fully expanded term. Okay, try number 5. Where root of R is same thing as R to the 1/2. Just bring that 1/2 down in front. There's not much more we can do beyond that. Okay, for number 6, you got 2 distinct, we can't separate the A plus 1, but the A plus 1 will be one thing, and then the cube roots of B minus 2C is another thing. If you want to rewrite it as log base E, you can, or you can leave it as ln for natural log. Again, you can have this as log base E, or if you want to leave it as ln. It's fine, it's just sometimes easier for us to see that clearly what the base is if we have the log base E. Now, we cannot separate the A plus 1. We can't distribute the log through anything that's a plus or minus inside the parentheses. It stays. We can't do anything with it. But one thing we can do is moving that 1/3 down in front.
So why can't you distribute it?
Because the log and the A plus 1, they're not outside of each other. This is inside the log function.
Oh,
So if it was like, if log was outside the parentheses, then we could distribute through, but this A plus 1 is inside. So it's not log of E times A plus 1, it's log of E of A plus 1, so, yeah, that's why.
And also, so like, so if you do ln, it's like ln, not like lne.
That's right, it's just ln, right? Either you write log base E, or you just do ln.
If you spend a parentheses thing, like that.
About, what do you mean that like these parentheses here?
Yeah.
That just means that this is something that's inside the log term. So if it was just log base E of X, we'll leave it as X, but if inside was more than that, I need to make sure I put it instead of parentheses, so to indicate that this whole thing is inside my log expression.
Cool. I thought you'd like just like use, like it'd be like natural log A plus natural log.
Yeah, so here's the thing is that log, natural log of A plus 1, this is not a standalone, this is inside the log function. So it's not the same thing as saying X times A plus 1, where I can distribute the X through. This is inside. So it's the same thing, like if I gave you sine of A plus B, I can't just distribute the sine through,
Okay.
right? This inside, so this is as far as I can go. Yeah. So just have to understand that these are not separate things. It's stuck inside this whole expression, so it's not, we can't do distributive property like we normally would with something that's completely outside of A plus one. Okay, so now going in the other direction, imagine starting from the expanded form and trying to put it back into condensed form. So let me just kind of go through the process. Let's say you're starting off with this problem and you're trying to get it back to condensed form. The way you do it is, if you see any coefficients, bring them up to the top as exponents. So the 3 will go back up as W cubed, the 6 will go back up as XC6. And now you're just having to figure out, where did these pieces go? And the way they do it is, you say log base 4. Every one of these terms will either go in the numerator or the denominator with your log expression. So anything that's part of a positive log is going to go in the numerator. Anything that's part of the negative log will go in the denominator. And that's how we get back to that point. Okay. So let me start off with this here. If I have log of A plus log of B minus log of C minus log of B, if I want to get back to my starting point, I'm going to say log parentheses with numerator and denominator. A and B are part of a positive log, so it goes above. C and D are part of a negative log, so it goes below. So let's see if we can. Let me go through 7 with you and then have you guys try the rest. So if I have 3 log 4 minus 2 log K, first, if I want to condense it, bring the 3 and the 2 up as exponents. Notice that 4 cubed and K squared, this is part of a positive log. K squared is part of a negative log. So the 4 cubed goes above, K squared goes below. And if you don't see a subscript under log, it's understood it's a base 10. Number 8, it just feels a little bit out of order. I rearranged it. I put the log base 2, 6x cubed first, then the minus log base 2, x plus 1 to the 5th second. Then it makes it easier for me to see, okay, 6x cubed is above, x plus 1 to the 5th is below. Try number 9. So first take care of the 1/3, the 1/3 and the 6th. And then you got to find a place for the 10, the H, and the G.
We're just practicing this today.
Yeah, that's all we're doing, just practicing with these products, these 3 properties here. Yeah.
For 9, the like 10 or 3, however you say it.
Yeah, you can do a cube root
Yeah.
of 10, yeah. So there's different ways that you can write it. If you want to put the H along with it, you can. Stick it under the 10, 1 and 2. Yeah, yeah, any of those variations are fine. All right, try 10 and 11. And your classwork will just be page 8 and 9. I'll show the answers as you guys go through them.
You can simplify it at the end, number 10.
You don't have to. You can leave like this, it's fine. I distributed through, but you don't have to. Yeah, I just cleaned up, but. That's fine.
Oh, so it can't,
It's on.
just not the.
Oh, no, we can't. Yeah, because they're not like terms. They're not like terms. If it was like, if it was 2m to the 5th
Okay.
minus 1m to the 5th, then I can subtract. Yeah, but if they're not like terms, I gotta keep them.
And number 11 is simply log like base 10.
That's really base 10, yeah. You can either show the 10 or leave it out, which is understandable. That's a shorthand way of saying base 10. Okay, so we're just practicing these expanding and condensing properties. So page 8, 1 through 7, and page 9, 8 through 14. That'll be all for today.
What do you do for the square root?
Square root is same thing as exponent to the 1/2.
No, you just. Log it.
Thank you.
Yeah, page 8 and 9. Yeah.
Do you make like the top negative, like how do you make that negative? Without like making it go to the bottom? Started plus.
Yeah, so the u minus 1, I can't separate it. That's one connected thing. Okay. I can only separate things that are being multiplied.
Sure, yeah.
Yeah, but I'll put parentheses around it just so I can protect it. Yeah, okay. Yeah, very good.
And then well, also, how do you do I the L?
Just leave it as ln.
It's like the same as log.
Yeah, it's basically log, same as log base E, but you can just leave it as ln and just treat it like its own unit. Okay, so 1 through 3 starts off pretty simple and then it gets a little bit more involved. For number 5, I show the work as log base E. On the board, I have it shown as not as ln, so just understand that they.
Also, you do multiply that.
Huh?
You do multiply the two fraction. Two.
Yes, you can multiply the exponents together.
Does it only like give me parentheses if it's like adding, or if it's multiplying or dividing? Like where I did the
Oh, you're talking about distributing?
Yeah.
Yeah, you can distribute exponents, but I can't distribute a log through an addition. Like this. This can't work. I can't do that.
or subtraction.
Or subtraction methods, that's right. The only time you can play with it is if there's if this multiplied or divided. If it's added or subtracted, it's stuck. It's stuck in this form. You can't go there. Part two. Back up here, back here, see the back, or down the back seats.
This 5 with the stereo. Put it with the log.
Define, define is good.
Okay, so maybe like this,
Yeah, it's log, it's base 10, it's log base 10.
and then do like this together.
Yes. It's to the one. It's cube root of same in this place.
What's a 5?
Oh, fine.
So I did one.
Oh, yeah, got it.
Yeah, but the 5.
That's right. Those will be the equation. Thanks. Okay, is anybody still looking at 4 through 7?
Like number 8, you like simplify this to one like simplify it.
You can simplify it, but you don't have to.
Pretty sure this is.
Anybody still looking at page 8?
Well, that's what they ever feel all the time.
Score cancel.
The other things, you know, that there was a question going something. Yeah. That's how it is.
Unless it goes through and it's kind of less about kitchen. So. Oh, need a calculator. Yeah. That's what it's. Yeah, that's all. That's everything. Yeah. They don't know how to sort of, it's five, roots, log.
Oh,
Minus 32, or 5, 332 squared.
I was at home spending a thing, you know?
Get Chelsea. Wait, is it multiple?
Not like a number, it's not.
Um,
As like three square, which would.
right, I think either's fine.
That would be.
Which is the fifth root of 32, and then 2 squared is.
A kind of an example.
In this mode,
What are you here?
Negative first, like it's where all the pieces are. And then you're gonna, it's gonna end up in the numerator. I'll fill it in.
it was about right.
For this, is this?
Not there's one, yeah. Anything with a minus is fine.
Yeah, so if you're young, you're questioning yourself, is that acid? Oh, bring it 33. Yeah. Of course, we actually would feel 57. You should round it up. Oh, that's how you do. That's great. Yeah.
So for 14, this feels a little bit complicated. I would distribute, get the parentheses out of the way first. And then you can clearly see, okay, the 32 and the 9 goes up top, the J goes below.
Oh. So it doesn't have to be like in order, like plus and minus.
Yeah, the plus and minus don't have to be in order. Whatever is plus goes up top, whatever is minus goes below.
So for 2 bits, it's 9, so it's like exactly fine, or for 2 bits, just like if I found. So I would think if they were.
I want us to, yeah, I guess I want us to be able to know how to, what it means. So the 32 to the 1/5, that's the fifth root of 32. 4 and 4 squared is, I'm sorry, it's 2. 2 squared is 4. So,
You heard back there, you're supposed to.
yeah, for now, I'll say
Okay.
you should, but then I still don't know whether everyone take points off. So,
We're gonna have a quiz over this.
no quiz, just a test.
Remember 13, can you just square root around the 6 minus 7 instead of raising it to the 1 half?
Yeah, that's right here.
Yeah.
Third is fine.
Okay. And like, how would you do the 32 to the 2 bits without a calculator?
Right. So 32 to the 2/5
Would you gonna think was?
is saying, what's the fifth root of 32? Do that first. So what 5 numbers can multiply to be 32? 2. And then you can square that. 2 squared is 4. So you shrink the number first, and then you raise it to a power. So for instance, here's another example. If I have 27 to the 2/3, right, shrink that number down. What's the cube root of 27?
Three.
Three, and then three squared is
Nine.
nine, yeah.
Thank you.
Yeah, that's it. So you can come up and get your phones, we're done with that. You can go.
I don't like having my phone on.
Yeah, so tomorrow we're gonna do.
I don't like having my phone on.
Property for Bronx. Those just.
Oh, yeah, we are, yeah, so I may try to get into 10.04, so we'll finish 10.03 first.
Okay, perfect. And I'm not gonna.
Yeah,
Yeah, I'm-
didn't know that. Coming to New York Packers. I did not. You guys were good. I'll take it. You're like the Giants for us. They're becoming New York Bills and keep signing like New York Bills.